Okay, we are into half angles, double angles, and power reducing formulas in this section. The first thing we want to find is double angles. Let's recall the double angle formulas first. All right. Now that we have our formulas written out, remember cosine's got a few variations here. We are going to draw out this angle in the second quadrant and find the pieces that we need so we can calculate sine, cosine, and tangent in order to be able to apply these formulas. If the sine is 4/5, that means that the y value is 4, the hypotenuse is 5, and the adjacent is 3. It's a 3, 4, 5 triangle. Feel free to verify that. But our x is negative because we are in the second quadrant. Now we can calculate sine, cosine, and tangent. For part A, sine of 2 theta is equal to 2 times the sine of theta times the cosine of theta, which is equal to negative 2 times 4 is 8 times 3 is 24 over 5 times 5, which is 25. For part B, the cosine of 2 theta is equal to cosine squared minus sine squared, 1 minus 2 sine squared theta, or 2 cosine squared theta minus 1. You can use any of them. We already are given sine, so I'm just going to use that. So that's 1 minus 2 times 4/5 squared. That's 1 minus 2 times 16/25, or 1 minus 32/25, which is the same thing as negative 7/25. Tangent of 2 theta is equal to 2 tangent of theta over 1 minus tangent squared of theta. And tangent of theta here is equal to opposite over adjacent, or negative 4/3. So we have 2 times negative 4/3 divided by 1 minus negative 4/3 squared. That's equal to negative 8/3 over 1 minus 16/9. That's negative 8/3 over negative 7/9, which I can then multiply by the reciprocal. That's going to give me negative 8/3 times negative 9/7. I can divide out by 3. The negatives are going to become a positive, and that is 24/7. Let's verify this identity where we have cosine 3x equals 4 cosine cubed x minus 3 cosine x. Now, I've got a 3x, which looks kind of like a double angle formula that I might want to use. The cosine to a third power means I want to probably do a power reduction. Let's try and see if we can break this up a little bit. The cosine of 3x is the same thing as cosine of x plus 2x. Which looks to me like a cosine sum formula. Let's recall that. That means that the cosine of 3x is equal to the cosine of x times the cosine of 2x minus the sine of x times the sine of 2x. I've got some double angles in here then. And this is just the left-hand side. Okay? Recalling the double angle formulas, the cosine of 2x is 2 cosine squared x minus 1, and the sine of 2x is 2 sine x cosine x. Notice that the right-hand side is all in terms of cosine, so I want to try and get in terms of cosine. So I'm going to replace my double angle formulas. So I have cosine x times 2 cosine squared x minus 1 minus sine x times 2 sine x cosine x. Again, this is still left-hand side. Distributing, I have 2 cosine cubed x minus cosine x minus 2 sine squared x cosine x. Again, my goal is to get in terms of cosine. So I am going to take my sine squared and turn that into 1 minus cosine squared x using the Pythagorean identity. Distributing into that term the cosine x, I have 2 cosine cubed x minus cosine x minus 2 cosine x plus 2 cosine cubed x. The 2 cosine cubed x plus the 2 cosine cubed x is 4 cosine cubed x. And then cosine x minus 2 cosine x is minus 3 cosine x. And that is the right-hand side of the equation. So we've actually verified the identity. Now we want to reduce powers. So we want to take cosine down all the way in terms of a single first power cosine. Remember that the cosine squared of x is equal to 1 plus cosine 2x over 2. Cosine to the fourth of x is the same thing as cosine squared of x to the second power. I'm then going to say that the cosine to the fourth of x is equal to 1 plus the cosine of 2x over 2 to the second power. And then I'm going to expand the numerator and the denominator. Remember that if you had a over b to the n, that's the same thing as a to the n over b to the n. This is the same thing as 1 plus cosine of 2x squared all over 2 squared. This is 1 plus 2 cosine 2x plus cosine squared 2x all over 4. But I want to do cosine squared of 2x. What I want you to recognize, though, is when I am taking this cosine squared down to cosine, I'm going to be using the power reducing formula. However, for a single x, I became a double x here. So for a double x, I'm going to take that times 2. And just to show you off to the side, the cosine squared of 2x is going to be equal to 1 plus the cosine of 2 times 2x all over 2. That gives me 1 plus 2 cosine 2x plus 1 plus cosine 4x over 2 all over 4 from before. So the green I'm replacing here is the cosine squared 2x. Expanding this out, I have 1/4, and then 2 over 4 is a half cosine of 2x, plus this is 1/2 plus cosine 4x over 2 divided by 4 still. That's 1/4 plus 1/2 cosine 2x plus 1/8 plus 1/8 cosine 4x. Combining the fourth and the eighth, I get 3/8 plus 1/2 cosine 2x plus 1/8 cosine 4x. If you didn't necessarily follow the eighths and the fourths, I'm using the fact that a half divided by a fourth is an eighth. And whenever I have 1 plus cosine 4x over 2, that meant the 1 was over the 2 and the cosine of 4x was over the 2 as well. We're using the half-angle formula to find the exact value of sine. Well, the sine of alpha over 2 is equal to plus or minus the square root of 1 minus the cosine of alpha over 2. And then the sine, the plus or minus sign, is determined by the quadrant that alpha over 2 lives in. Alpha over 2 is 165. That means that the angle, the half angle, is going to be in the second quadrant. And the sign in the second quadrant, the SINE sign in the second quadrant, is positive. So this is going to be a positive answer. So using the formula, the sine of 330 over 2 is going to be equal to the positive square root of 1 minus the cosine of 330 divided by 2. That's positive. 1 minus the cosine from the unit circle is the x value at 330, which is root 3 over 2. I'm going to find a common denominator for the numerator. That's going to be 2 minus root 3 over 2, and that's divided by 2, so that actually becomes divided by 4. It's actually all inside the square root. That's 2 minus root 3 over 2, all divided by 2. That's actually the same thing as the square root of 2 minus root 3 over 4, multiplying by 1/2 instead of dividing by 2. That is the same thing as the square root of 2 minus root 3 over 2, splitting the numerator and the denominator because the square root of 4 is 2.